share my screen first. Okay. Then we can go ahead to start. Make sure. Can you see my screen?
Yes, we can, Dr. Lucy.
Yes.
Okay, let me see. Show. Oh, hold on. Okay. It's good?
Yes, it's good. Thank you.
Okay, should we start? I cannot see you all. Okay, I can only see my screen. Okay.
Yeah, I think we can get started. So if I think everybody's should know Dr. Lucy, right? So we have been since some weeks, and I think we can get started. Do you have kind of the slides, everything ready, Dr. Lucy? I cannot. Maybe yeah, it's good. I can see it now. Yeah, we can go ahead. Thank you.
Okay, so you are started recording, right?
Yes, it's been recorded.
Okay, good. Okay, let's start. So hello everyone. So today I will talk about spatial data and the spatial database management. Okay, so okay. Oh, hold on. Can I go to previous one? Okay, so last week, Tapas gave a very good presentation on database management. So like about relational database, CR modeling, primary key, SQL language. So I think by now you all have a good, you have done a lot on this topic. So for today, I'm going to extend this topic to see how we can use database to store, manage, and retrieve spatial data, and why existing database, those non-spatial database cannot work well with the spatial data. Why we need a spatial database management system. So over the next maybe an hour, so I will first revisit the database design by highlight some of the maybe couple of two important concepts in this topic. Then we'll move to spatial database management and design to look at what's the issue when we're using existing database to handle spatial data. And also we'll introduce GIS software, and also demo some applications like this, how to handle spatial query in GIS. The last topic will be, I would like to introduce an application, ArcGIS Survey 123. So we know when spatial data is a part of our everyday life, and for our project, we might also include spatial data like animal data, or we talk about the plant data. There's a spatial information, but how can we can easily incorporate spatial data into our current data? The Survey 123 will be a good application, particularly when we work in the field. So this is the outline for today's topic. So far so good. Can you hear me?
Yes, I think I can hear you well.
Okay, good. So let's get started. So before we to understand what drives database design, we definitely needed to know what's the difference between data and information. So data actually consists of raw facts. The word raw here indicates the facts may have not yet been processed, and the information is the results of processing the raw data in order to reveal the meaning of the data behind the data. So here, this figure shows an example of how we transfer raw data into information. So assume we want to collect the faculty data in a university. Then from the data, we want to find out the information like what's the makeup of the faculty, say what's the percentage of adjunct or percentage of assistant professor, or how about female, male, those information. So the first section here, this is the data, simple data entry form. We use this to enter each faculty information. And then whatever we entered, we are stored in a database. Say, for example, here this is a table or relational database. And each row is represents each faculty. So usually each university has probably over 1,000 faculty members. Like in 10 UCC, we have, I think, about 1,300 faculty members. So if we just read through those thousands of lines or rows, it's hard to get the insights about the information we want, like what's the percentage of adjunct faculty. So for that purpose, then we can transfer the raw data into maybe summarize the table, like the section, the part C here, or we can use a pie chart. This is a graphic format to represent the information. So we can easily say, yeah, it's about 20% of faculty are adjunct. So this is this way how we transfer raw data into the information. So from here we know the data is the foundation of the information, and information is the bedrock of the knowledge. And the knowledge that means the understanding of the information. And we always wanted to derive new knowledge from the old knowledge. So for that purpose, in order to, so in this way we can have a good like a decision making for whatever we need. So for that purpose, we definitely very important key is we need to have a very accurate, relevant. Hello? Okay. We definitely, the very important key is we need to have accurate, relevant, and timely information. And how to get this kind of information, it all depends on what kind of data we have, whether the raw data, whether it's accurate, and how to store, represent the data. We should present the data in a correct format so it's easily to handle and process in order to discover the meaning behind the data. So that's the reason. So this is, oops. So data management has the job to generate, store, and retrieve the data. And then efficient data management usually depends on the use of a computer database. So here, this is the database, and this is a database system. So from here, we can see the database is a collection of shared integrated structure that stores all kinds of raw data and also the metadata. So here I like to highlight the metadata. So in addition to the raw data that we often use, metadata is also very important. They provide additional information about the data we have. So for example, if we have a distance data, the distance, those kind of values. In addition to the numbers, the value, whether it's 100 miles or 100 or 2000, whatever, we also want to know what's the unit. It's a mile or it's a kilometer or whatever. And also we want to know what's the source of the data, who created data. Those will help us to figure out whether the data is accurate or not. We need to use also accurate data. As we mentioned, the accurate information depends on the data we use. So keep in mind when we create or design database, we also need to think about to include the metadata. The metadata will give us a more better picture about the data we have in the database. And the other thing is the DBMS, I think last time we already covered. So here, the database management system. So just have a quick review before we move to the topics I wanted to highlight today. So for the DBMS, we know this is a collection of programs. We use this to create, manipulate, retrieval the data we have. So this serves as the intermediate level between the user and the data. So the DBMS should be able to receive the request from the user and go to database to retrieve whatever the data we need to fulfill the request. So we having a DBMS between the user and the data will help us to reduce the data inconsistency. And often the data inconsistency happened because of the data redundancy. That means ideal, we want to store the data, same data in one single place, not in multiple places. Otherwise, when we update, we might forget to update one place, but we might update in one place, but not the other place, or some kind of other mistakes we might make. So those will cause data is inaccurate because we have to make sure data is accurate. So so last time we focused on the relational database. This is a type of database even if we developed maybe around 1970, almost 50 years ago, but it's still a widely used model. And we know the data, they are all represented in tables. So that's the reason we call it relational database. Actually, relation is a mathematical term to represent the table. So I'm not. We already covered this, so I'm not. I will not go again. But we know. So last time we talked about the ERD modeling. So those are used to link how tables are related. As we mentioned, a database system not just store one table. Most of the time, it would be multiple tables are involved. So we use ERD to indicate how tables are related to each other. But there's a question to have a good design of data, relational database or tables. We might have a question like, what are the attributes we should include? We should put together in one table. Should we separate or not? So this is a question we will ask when we design the table. So for example, let's look at here. So in here, this is when a company they use a relational database or table to store the project information and the employee assigned to the project, and also how to charge the customer. So for the project, we have project number and a project name, and the employee number assigned to the project. In addition, we also have employee name and the classification job for the employee. And for the charge information, the company, they charge their clients or customers based on how many hours that employee work on this project. And it depends on the job classification. The hourly charge is different. So for example, electrical engineer charges $84.50 per hour, and the total is the first person spent 23 more than about 24 hours on this project. And then we can see the each project will be assigned to multiple employees, not just one employee. And for the job classification, as long as the same type of job, the charges is the same, no matter whether it's so no matter whether it's John or so for database design, we have John and Alice, they have the same charge to the client. So right now we put all this information into one table. So the question is this a good design? What do you think? Who want to try?
Anybody wants to chime in?
To try to say whether is this a good design? Should we put all those attributes in the same table, or should we separate put in multiple tables? Again, a good design means we want to try to reduce data inconsistency. The data inconsistency is often caused by data redundancy. And also, for example, if the hourly charge for data designer is increased by $10 from 105 to 115, so we have to go to the table to update this information. Right? Ideal, we hope to only update one place. But currently we have to update 1, 2, 3, 4 places. And
Dr. Lucy,
yes.
I don't think this is a good design.
Yes, why?
We have a lot of data repetition, and we also need unique identifiers.
Yes. Great. Yeah, that's a good point, because a lot of data replicate here, so that's the reason might cause some issues when we needed to update. So to have a better design, first we need to first think specify what's the primary key. The primary key can be one attribute, or can be a combination of attributes. That means it could be involved more than one. And last week we talked about the primary key is important when we design a table. So in this case, what do you think, which attribute or combination will become the primary key? What do you think? Anybody want to try? The primary key is that means they can uniquely identify any row. So given the value of the primary key, we can identify any row. That means each row will have a different value for the primary key. So for example, definitely project number itself cannot be a primary key because the first 4 rows have the same project number, right? And the same employee number itself cannot be the primary key because we say 103, how many times? 103 is fine, but which one? Depends on the employee because employee can be associated with can be involved in more than one project. Say for example, do I have an employee that's involved in more than one project?
Employee 114 does.
Yeah, okay, yes, 114. She is involved in project 18 and also project 25. So the employee number itself cannot be a primary key. Same for the others. So what do you think? And again, keep in mind, we can use a combination of attributes become the primary key, not just one single attribute. So any combination of attributes, they are unique among the rows we have here. Should be project number and employee number in this case. So these 2 attributes together become the primary key. Okay, any question? So now next, we need to figure out how other non-primary attributes, how they are related to the primary key. So project number depends on project name depends on project number only, right? It doesn't involve any, it's not related to employee number. And the employee name, job classification, they are only related to employee number. So as long as we know employee number, we know the employee name and the job classification. And the charge hour, the actual, this one depends on job classification. The job classification depends on employee number. And the hours, why we need a combination of both project number and the employee number, because hours, how many hours the employee work on this project depends on both employee number and project number. Okay, so this is the how the non-primary attributes, how they relate to the primary key. So this is called a dependency diagram. So once we figure out this dependency, how they are related, then we can move on, say, to have a table that only includes the primary key and their associate attribute. So for example, we can put a project number and the project name together in one table. Employee number, employee name, job classification in one table. But for hours, we have project number, project name, and hours. Those three attributes put in one table. And for the charge hours, because it only depends on the job classification, so we can just put these two in a different table. So in this way, we can transfer this one single table actually into 4 tables. So instead of use one table, actually it's better to use 4 tables to store whatever the information we have here. Does it make sense? So in this way, if we have to update the charges for job classification, we only need to go to this table to make one single change, right? And the same thing, if we change the project number, a project name, or the project number, then we only need to go to this table to make those changes. We don't need to bother the other 3 tables. So again, those this design will minimize the data inconsistency due to the same information stored at a different location, different places. Right. So far, so good. Any questions?
I think I have a small comment. I think I really like this demonstration you made, Dr. Lucy. I think it's very helpful. The way we discussed last week with the whole big table, I think it makes more sense now to have kind of small tables with small, two columns. I think it makes more sense and how to connect those two together. I think it's more interesting now, and I really like it this way.
Okay, thank you. And actually also, we can also improve this design. So what do you think? Is there any more improvement we can make? Say, for example, for employee name, right now we put, if you go back to the previous one, so we put the employee first name and last name together in one attribute. But say, for example, you want to search all employees, their last name is whatever. It's difficult, right? So we have to extract each employee name, including first name, last name, and we have to separate, figure out, extract the last name part. Then we'll see whether it's the same last name we need. So for that purpose, actually we can further improve the design by using maybe 3 attributes: first name, middle name, and the last name, instead of just one single attribute to represent employee name. And the same for the job classification, we might have a ID for job classification instead of just have the description, the charge. So those changes might help improve the data process and retrieval. Okay, so again, last time for the ERD modeling, those focus on how the tables are related. And for the topics we covered today right now, it's focused on how we design the table. What attributes should be included in one table? Should we put using multiple table or just put in the same table for those attributes? And then again, the purpose is we wanted to reduce the data redundancy. We can minimize the data redundancy, but we cannot complete we cannot completely get rid of redundancy. Why? If you look at the design we have here, project number will start in two different tables, right? This table and this table both should have a project number, and the employee number also in the two different tables, same information, and the job classification is in the same table. So that reason if we have an ID, for the job classification will be better instead of the description. Why we need those repeat information? What do you think? Can we get rid of the, say, can we just store project number in one single table? Say, for example, if we get rid of project number from this table, then what will happen? Then we cannot link this table together, right? And the same thing, if we don't have job classification here, we cannot link this table together. So those repetition or redundancies is required in order to link table together. And we link table through the foreign key. So last time we talked about primary key, and also foreign key is also an important concept in relational database design. It's used to link tables together. Okay. And the one thing, the foreign key difference from the primary key is if one attribute is specified as the primary key, you cannot have no value. That means you must have the value before you put to the date table. But if this is an attribute, if this is a foreign key, it's fine. When you enter the data, you don't have the value. You can add later. Okay. Any question? So in summary, for the good database design, so those are some criteria. So we want to use each table to represent a single project and only include related information in the same table. And also we want all non-primary attributes. They are fully dependent on the primary key. So how we to do this? So we will figure out how the attributes are related to each other, which one depends on which one. Then we can just gradually break those relations or take into new tables. That's what we did. Okay. Does it make sense? Okay, I think if no question, so now next, so we know how to design good relational database. So the next one is we know that DBMS can be efficiently access, process, retrieve date in the database, and also the database are integrated, shared with others, and also we can also handle like those security backup those issue. So our is good for non-spatial data and non-spatial query, but Azure one disadvantage is it's not efficient for spatial query. Why? So before we look at this one, let's look at which one is a spatial query, which one is not spatial, non-spatial query. So assume we have two queries. The first query is to ask what are the names of all bookstores with more than 10,000 titles. And the other query is we wanted to, from the database we have, to find all bookstores. They also should be with more than 10,000 titles, but the bookstores should be within 10 miles of, say, TAMUCC. So but these two queries now quite similar, but one is spatial and one is non-spatial. So which one is spatial, which one is non-spatial? What do you think?
Any students, you want to make a guess?
Within 10 miles is spatial, and a bookstore more than 10,000 titles is non-spatial.
Yes, that's right. So using the current relational database, if we have bookstore, name of the bookstore, how many titles they have, we can easily retrieve this information. But in order to perform the second query, we also need to have the location of, we have to know the location of each bookstore, and also we have to have the information about where's the location of A&M Corpus Christi, and we also need to calculate the distance between two locations, right? If we have those capability, then we can handle this query. Otherwise, it's difficult. So for that purpose, in order to answer this question, spatial query, we have to store spatial data, right? And for spatial, let's have a brief introduce spatial data. So what's spatial data? What are the basic components of spatial data? So spatial data is also known as spatial information or geographic. It's also called the geographic information or geographic data. When we talk about spatial data, many people will just think about the map. Actually, yeah, although map is a good start for spatial data, but spatial data actually means more than a map. So like any information, if they have a location, whether it's represented on a map, is a spatial data. So for example, here, look at, so this example for the driver license. Actually, the data for driver license is a type of spatial data. So from here, we have the name, date of birth, the whatever ID. Those are the basic information about this driver. And in addition, we also have the address. And based on the address, we can link to a location on the map. So similar, this is another example about the parcel data. So we have the name of each house, the householder, the address, and some other information about the house, whether how many stories, the color, or whatever. So the similar, So we have location information and we have attribute information. The location information describe help us to find out where this object resides on the Earth. And the attribute, those non-location information, they provide some other basic description about the data. So these two kind of information, spatial location and attribute information together create spatial data, and then they can place it on the map. So spatial location and attribute information are two basic components of the spatial data. And we use spatial data. The actual spatial data is a part of our everyday life. Like for example, if for our work, for the we also always need to know where's the location of our case study. Like we have plant data, we also need to know where's the location of each plant. And for the animal, we also need to know where this animal is located, right? And outside of the work, we definitely use spatial data a lot. And we often use cell phone to find the nearby restaurants. And also we scatter the direction from one location to another. So this involves spatial data. So the based on the shape of the spatial features, we have three basic types: points, lines, and polygons. So points is just a single XY coordinate location, and the 2 points will form a line. And if we have 3 more points, as long as they form a closed loop, this becomes a polygon. So those are the 3 basic types of spatial feature. So for the spatial query, which is the main job for the database that stores spatial data, we need to be able to store spatial features. Say, look at this example. So here we have, assume this is a polygon. This is a census block. We use a polygon to represent it. And the census block, by the way, is the smallest geographic unit used in Census Builder. They use this to report like social demographic information, like population within each block group, each block. And the block in a city, the block is formed by the street segments. So all sides, they are the street segment from one intersection to another. So assume we have a nice polygon shape for this block, and then we have the population, say 1005. And then we want to store the population in each block in a database, and definitely we also need to have the location, the coverage of the boundary of this block in the database. So how to store this information? So ideal, we hope we can have each row in the table to represent a single block, right? So this way, that's we hope to have this way. So the name, 1050 is the name of the block. The population in this block is 1839. And the boundary is these 4 lines, and the line will have the XY coordinate for each corner. So from here, this is from this point to this point, and to here and to here. So that's the ideal. We want to have this storage or format to represent block. Is it doable based on for the non-spatial or traditional database management system? So the question is the polyline. So we have a polyline. Is this a data type supported in relational database management system? We know, we probably know, right? Because we have a basic data type, the numeric date, Boolean or thing, but we don't have polyline or point. So that's not doable. We cannot, if we write something like this, the DBMS, traditional DBMS cannot understand. So instead, we have to end up with using these 4 tables to represent the block. This is simple geometric shape. We have to using this 4 table. So we have 1 table to store each points, right? Each point XY coordinate. Then we have a table to store each line. And for the line, we need to what's the end point, what's the points from this line. And then we have a polygon to store the lines of those associated with each block. Then we can have this table for census block like name, area, population, boundary ID. So this is it's doable, but it's very inefficient, right? So that's the reason why we need a spatial database management system to handle spatial data and the spatial query. Make sense? So for a spatial database management system, so it's a software that can work with underlying DBMS. So it's not a brand new, it's developed based on the existing DBMS, but add functions capability to handle spatial data and spatial query, and also the spatial indexing. This means usually for spatial database, huge amount of data, spatial data involved. So how to quickly speed up spatial query, that's spatial index. And for the software, software we have the current MySQL can extend their capabilities to support spatial data and spatial query. And also there's another commonly used as PostGIS. And before we look at some examples, so let's just say how spatial data is stored. So no matter which software we use, recall for spatial data, we have 2 components, spatial location and non-location attributes. So when we store the spatial data, no matter whether it's the point line or polygons, so we separate the spatial location and non-location attributes. We use the traditional relational database to store those non-location information like a driver license, name, height, ID, whatever. And for this location, for the edges, which usually is the like XY coordinates, the edges, those we put in a separate file. They both have the same ID. We use this ID to link these 2 information together. So giving an address, we can easily locate what's the name of the person living in that address. So that's how we store spatial data in a database. And when you talk about the format, I will talk about commonly used simple format. This is a shape file. So when you deal with spatial data, most likely you will deal with a shape file. So shape file this format is developed in by Esri is a simple format to store the location and attribute. So again, we use point line polygons to represent the shape of the spatial features. And this format is not just one single file, as we mentioned previously. We will store the information non-spatial, non-location, and spatial location separately. And the same for this format. So this format actually consists of a collection of files. And both have they have the same file name prefix. Like if it's a row, we have rows or same file name rows, but they have different file extension, and it depends on which extension they store the different information. And all those files, they are stored in the same directory. And there are three mandatory required files, and with SHP, SHX, and DBF. The SHP, this is a main file used to store the geometry, to represent the location of points, and what are the points to make lines, and what are lines to make polygons. And the DBF, that's the database, relational database, stores the non-location information. Okay, and then also have the index file. And you will also see other files with the same file name. They are not required. The three, they are required. And in the data we have, like for example, you can think about it, this is the SHP file, this is the DBF file. So the number of records, they have a one-to-one relation between these two files. So the first line in the location file actually corresponds to the first row in the DBF file, right? So they have to be in the same order in order to link them together. And also they have kind of ID to link. Any question? So far so good? Okay, I think I have to move on. So here, this is an example to using MySQL to store spatial data and also conduct a spatial query. So assume this is we have, for example, if we want to find what are the 5 kilometer, what are the hospitals within 5 kilometer of I think this one is our campus location. Okay, so assume we have 3 hospitals. So we can build a table to store the hospitals. And in the hospital, we have name, we have geometry. If you look at the geometry, so this is a data type. And within here, for this function, as this function is to construct a point, and then we have to provide latitude first and then longitude. So in this way, we add 3 hospitals to the database, and we can use this select SQL statement to find out what are the hospitals within 5 kilometers to this location, our campus location. So if you look at here, this function st distance, this is to calculate the distance between 2 points on the Earth. Okay, so we calculate distance between this point to the all points in the table, and if the return is in meters, so if for 5 kilometers, that's what we need, right? So this is an example, but you will see that's for this simple queries, we have to write so many sounds a little bit complicated SQL statement, right? So fortunately, we have a GIS software. Any GIS software can handle spatial query. So instead of writing a SQL statement by ourselves, they provide a nice interface for us, so we can just using this interface, we don't need to bother the specific SQL statement. So this is a two interface, one for spatial query, one for non-spatial query, one for spatial query in ArcGIS Pro. We'll introduce ArcGIS Pro shortly. So here, this is select by attributes. Say we can just select, okay, what we want. The county name equals to 31. So we just use this interface to put whatever we have. Actually, you will see this is the SQL statement, standard SQL statements to select whatever we have. But you don't need to write this part. You just plug with the interface. Okay, the SQL statement will be automatically generated for us. And for the spatial query, actually spatial query is deal with the spatial relationships, like whether the schools are within county, or whether two states they share the same boundary in their neighbor, or what are the bookstores within 5 miles of one location. So all those the spatial query, those methods, they are also pre-built for us. We can just based on whatever the data we have and whatever the task we want to do. So we select those methods. But behind there's a SQL statement to process. But again, as a user, we don't need to worry about those complicated SQL statements. So that's the one I think by using GIS. So GIS is as geographic information systems is a framework to get, manage, and analyze data, particularly for spatial data. The root of GIS is the science of geography. And for any GIS, it provides tons of functions to help us to like create, work with spatial data. We can easily manage, analyze, visualize, and share the results with others. Okay. So when we talk, there are many GIS software. Some are open source, free, like a QGIS. But for us, the world leading project is ArcGIS, developed by Esri. So the ArcGIS is a family of client software, includes many products, including ArcGIS Pro, ArcGIS Online, ArcGIS Server, and many other products. So the ArcGIS Pro is a desktop GIS application. That's you have to download the software, install it on your computer, and then you can work on with your spatial data to perform spatial, to store spatial data, perform spatial query, and solve other problems. And also they provide a lot of function to make a nice maps. Although you can make a map in Excel, but if you want to have a fancy map, ArcGIS Pro might be a better option. That's ArcGIS Pro. And ArcGIS Online, also, this is also a very popular software, very popular products. It's a cloud-based web application. They have quite similar function as ArcGIS Pro, not as sophisticated as ArcGIS Pro, but for most of work, we can just use the ArcGIS Online. So in other words, you don't need to download, install ArcGIS Pro on your computer. As long as you have web browser with your internet connection, you can work with your spatial data. And it's also it's easy to share your map or other results with public. And whatever you have in your ArcGIS Pro, they can also easily work or share with in ArcGIS Online or other software. I think I sent you an email to invite you to join ArcGIS Online, our university's ArcGIS Online. You might already have actually College Station and Kingsway, and they also have ArcGIS Online. We have license, so you can get a license through your university. But right now, during the summer, for the temporary, I invite you to join our university's ArcGIS Online, and then I also create a group. It's AG2P_2020. So we can share whatever we have within our group. So let's say I like to demo some. I only have 30 minutes, so I will demo some the use of ArcGIS Online and ArcGIS Pro little bit. So for example, here we have Excel file. So here, those are the parks in Arkansas. Right, so each park we have ID, we have name of the park, we have latitude, longitude. Right. So if we go through the table, even if we have the location information, we have no idea where each park is located. Say, for example, what we wanted to find out which park is close to the Arkansas River. We cannot answer this question, right? So, but if we can make a map, put location those park on the map, we can easily to see it. So if we have, you can definitely do ArcGIS on Pro, but let me show you in ArcGIS Online. So ArcGIS Online, where's ArcGIS Online? Okay. You can, I think I already signed in. I will sign in again. Now for you, I think you were using don't use this one using ArcGIS Online. This is for students within it's our TAMUCC students, then we use this one. But for you, use so from here, if you go to my content, this is a place you can upload your information. Say, for example, we can, where we are, that's my content, right? So you can go to a map. You can add a layer from file, which is you can add like CSV file as long as it has location attached. Okay. Oh, oops, I need to select file, and I have it's under presentation. So here So you import the layer, and you have to specify the latitude and longitude. So that's what I have. So here each dot represents a park, right? Because I already did, and you can easily change the way how you want to represent the park. Okay, and due to the time, I'm not going to detail here. And based on here, so you can see, okay, which one so you go to here. So like, for example, like the park here, this park, you can click, okay, to see the name of the park. Actually, this park is close near to the Arkansas River, right? So that's ArcGIS Online. So you don't have to download, install ArcGIS Pro. And then we can handle spatial data. Then in ArcGIS Pro, so this is ArcGIS Pro. If you look at here, they have tons of thousands like a process tools we can use to process spatial data. So let's look at this example. So here, assume we have 4 gym locations in Wilmington County in North Carolina. And they wanted to expand their location, say maybe add 1 more location to reach out to the customers that are far away to the current location. So for that purpose, we need the location of the current gym, right? Those are 4 locations. And we also need to know where are our current members, where are they stayed, where do they live? So those points, blue points, each point represents a member of this gym. So we assume usually people would like to travel within 5 miles to go to a gym. If it's more than 5 miles, they don't want. It's difficult. All those areas will be considered as the service coverage gaps. So we wanted to put a new location, add a new location which that have most members live more than 5 miles away from each of the existing location. Is it right? Any question? So far so good?
I think I have a quick question, Dr. Lucy. So if we wanted to get the kind of coordinates of all of this for, let's say, to put on our database, we can do that in Excel. Can we export this in Excel and put it on a database that we are creating? Is it possible to do that?
Yes. Yeah,
Okay.
if we have Excel file has the location, that's the one I show you. The park, for the park we only have the location, so we can easily put on the map. And the same, as long as you have the latitude and longitude for each gym location or member location, you can easily to do it. You can just like add the data, XY point data, that will be on the map. If you look at it here,
Oh,
you can,
okay.
yeah.
Yeah.
Yeah. So for that purpose, what do you think? What kind of spatial query we should do? So if you look at here, if you open the attribute table, so here, this is a non-spatial, non-location information. It's the same. That's the non-spatial information, right? But the spatial information is stored in a shape file with SHP, right? So if we wanted to search the name of the gem, we can use the attribute select by attribute. This was same as non-spatial SQL. But for spatial query, like we want to find out where are the members. They are not within 5 miles away of each member, each current gem. So what we can do is we can also select by location. We want to select a member, right? The members, they are within a distance of gem location. We put 5 miles. Right. Then you select OK. So those members are within 5 miles of each current gem. They are highlighted. And those not highlighted, those are the members not outside of this servers. So in this way, we definitely wanted to put a new location, maybe someplace around here. Is it right? So that's a spatial question. Using this tool, we can help to answer this question. By the way, there are more than one way to do it. Instead of using this select by location, you can also, for example, so that's clear. You can also using like a buffer. You can draw a buffer around each current location. Then you can use a selection. You can use within, like for example, you can use complete within. You will get the same result, right? I think I have. So that's. I think I only have 15 minutes left. I will move to. I will stop demo and move to the last topic. Let's. I would like to introduce ArcGIS Survey 123. So you might have a question. Like for example, yes, we need a spatial data, but our current database doesn't contain spatial data. How can we do? What's the easy way to add the data? Like for example, we can have a CSV file. We can manually put the each location of the plant into the database. But assume we have 1,000 plants, it will be painful. And also, so particularly if we work in the field, we hope to be, when we collect the data, we can collect the spatial data at the same time. So that's the purpose for the ArcGIS Survey 123. So this ArcGIS Survey 123 is a product of ArcGIS Online. It's a simple form-centric data gathering solution to create and analyze survey data, including to collect spatial data. When you look at the design, you will see this is it's similar to other like a monkey, survey monkey or Qualtrics. Whatever you see is whatever you get. What you see in your design is whatever you get in your final product. And the nice thing for the ArcGIS survey is we can collect the data, particular spatial data, through like a cell phone. And even if there's no internet connection, we still able to collect data. Like for the Qualtrics, if we want this kind of a function, you have to have a special. You need to add. You need to have an additional permission to do it, right? And again, we can collect pointer data, polygon data, and image line or whatever. So I think I'm going to, I will use 10 minutes probably to demo the ArcGIS survey 123. So if you go to ArcGIS online, you can try to see whether you can log in. Oh, where's ArcGIS? So if you go to ArcGIS online, here, by the way, if you want to download ArcGIS Pro, once you log in, you can go to my setting. And here on the license, you can download ArcGIS Pro to your computer. But if you want to stay with ArcGIS Online, that's fine. So if you click this tab app, you will find the survey 123. And whatever you have, your create survey will be stored here. So for example, this is one I create I created yesterday, like to help a homeowner association to collect their community's information about how the residents prepare for the disaster, like for example hurricane. So if you look at the table, the survey we have, you can put your name. So here, as you can add a map. Here, this is the interface we have to design the table, design a survey. So here you can easily add a map. So that's the map we add. And you can, if you look at what we can do, so you can put whatever the background you want, and then you can also have set up which level you want to have the user to point the location. So whatever you point in the location, they will highlight the latitude and longitude. Okay, and also for here, you can this is a place to allow the residents to put their home address. If they want, you can if you can another thing for the latest ArcGIS survey 123, it's you don't have to have a user to type the address again after they already point their location. You can still go to you can use a calculation to match whatever the address to match the address to the location you point on the map. So that's very nice. And for the map, you can allow user to point the location, draw a line, or draw a polygon. And for the other function will be very similar to a regular survey platform. The map, address, and also the image, those are the nice thing for the ArcGIS Online. So in this way, we can easily collect the spatial data when we are in the field. Okay. So once you finish it, you will save, then you will publish. Okay. And if you publish, I think I already published. So if we go to setting, or go to here, go to here. So there's a survey link and a QR code you can share with whatever the public or the members in your group, so they can use this to collect the data. But right now, actually, if you try this link, it doesn't work for you. because right now I haven't shared this with everybody. So you can go to collaborator here. You can make who you wanted to be able to submit the survey. Like for example, we can have the only member in our group. Okay, they can use this survey to submit the form. And one thing is, one thing when you make the survey, if you want to use this survey to collect data, one thing you want to make sure you select this part. That means the users they can only or they only can submit their data. They cannot share with others cannot see their data. So in this way, it's a kind of security issue because, for example, maybe you don't want other people to see their home address or whatever. Right. So once I save to make it shareable within the group, now you can try again to see whether you can access to this survey. I think right now you should be able to. If you join our member, if you join our ArcGIS online, I think right now I will make it public. So in this way, even if you haven't joined, you can still try this survey. And once you have the survey, you can see the results in all different form, like a table, a graphic, and then you can also export the data. You can export the data to like a CSV file or in a shape file, and you can open in map view. So that's it automatically generate a map based on the survey you have, and from there you can make all kinds of web application, add more functions to your survey. So this is the survey 1, 2, 3. You can also download. There's an app. You can download the app to your iPhone, to your phone. Then in this way, even if there's no internet connection, you can still using this survey to collect data.
Dr. Lucy, I have a quick question. So,
yes,
is it like a pay? Do I need to pay for the subscription for ArcGIS and this survey 1, 2, 3?
no.
And second question is there a limit? Let's say I think a couple of other surveys they have, let's say 400 people maximum limit or something. Is there that limit for this software?
No, there's no charge because right now you are the member of our TAMUCC organization, so there's no charge for any member. You have the license. The same, you can go to your university, contact the GIS department to join, and there's no charge either. And also there's no limitation.
Oh, that's good. Thank you. A couple of other softwares, they do have, let's say, 400 people or 500 people limitations. So I'm just wondering. But, this is very interesting for me, especially for animal health. We do use a lot of like disease outbreaks, like kind of where the disease was seen in the past. And I think this is very helpful, fascinating to see how we can map those all in the system. And even on the tablet or even on the computer and the phone, that's very helpful.
Yes, I feel like if you want to go to field to collect spatial data, the spatial data survey 1, 2, 3 will be a great product to use. And also you can work even if there's a limited internet connection. Yeah. So here, like we summarize the workflow. using survey 1 to 3. So you create a survey, share, publish, and share with whatever you want to share. Then you can analyze and make a map or a web application. And for the more information, you can go to this link, find all kinds of information. I think I'm using almost entire 1.5 hour. Sorry for the long talk. I think.
Any questions from students? And this was very interesting. I think I learned a lot.
And one
Any
thing
burning
also.
questions?
And also one thing, if you want to showcase your project, the story map is also very great product you can consider. This is a story maps. You can create all kinds of story map. For example, where's the story I have? Where's my story? If I go to, okay, so for example, so you can use this, you can use map to tell the story, right? I think probably for our project, at the end we can consider about this map story to present the final project. You can, if you are in ArcGIS Online, go to same, click launch this app, so you will find where's the story. Go up here, ArcGIS story maps. And they have a lot of themes they're already built in. You can use. Also, okay, I think I'm going to stop here. Any questions? Sorry, it's almost 5. Do I need to how to stop?
Maybe if students they don't have a question, I have one question. Kind of, maybe it's a stupid question, but can you go to your presentation where you have that MySQL script? My question is, like, you put the coordinates, right? So I think you have you can put a point and you can get coordinates from that MySQL. Can you do that for area? Is there a way to get information on area from, like, let's say if it's a polygon or a square, like, can we get area from, like, MySQL script directly?
Yes, so you definitely can. Like, as I mentioned, if we go to, let me go to my survey. So for example, if we go to, where's my survey? This is survey. If we go back, we go back I think this one, right? Design. So same, for example, if we wanted to add another map, okay? So you add another map. So here, for the join tool, see, there's an option. You can choose point, line, or polygon. Right here, you can put a polygon, and you set up the base map. So for example, same. So then, whatever it will be, it will allow us to draw a polygon. Okay. I think we have to publish. Yeah. So again, if you want a polygon, go back to. So go back to map here. If you want to polygon, you select the drawing tool is the polygon area. If you want a line, you select this option.
Yeah, I think this is helpful. I think we're almost about time where it's all 5:01. So do we have any questions from any students? If not, I think we will call it a day. Thank you, Dr. Lucy. It was really, really interesting. I really enjoyed a lot. I think I learned a lot of new tools like Sorbet. Wanted this Sorbet. I think I'm gonna try it sometime, and even GIS. That was very helpful session. So I really appreciate your time, and I think next week we'll learn more on database and maybe start our project as well. So thank you everyone for hanging here. It's almost like 5:01, and I think we'll end it here. We'll call it a day, and maybe see all of you next week.
Thank you.
Thank you. Bye.
Thank you
Bye.
very much, Dr. Lucy. Bye bye, everyone.